So an object's velocity is given by the function v of t equals 3t squared minus 12. So this would be probably measured in feet or meters per second. And we want to find the displacement and total distance traveled on the interval 1 to 3. So now displacement is going to measure the difference between where we start and where we end, whereas total distance traveled is going to add up everything. So if we happen to move, let's say, looks like my velocity starts negative here, so if I end up moving backwards and then forwards, displacement is going to measure this distance, the different distance between where I start and where I end, whereas total distance traveled is going to add up both this movement and this movement. So let's start with displacement. For displacement, we simply need to integrate our velocity function over our interval. So we need to integrate from 1 to 3, 3t squared minus 12 dt. So we can find our general antiderivative here, t cubed minus 12t. We're going to evaluate that from 1 to 3. So plugging in 3, and then plugging in 1, gives us 27 minus 36 here, and 1 minus 12 here. Alright, so that gives us negative 9 minus a negative 11, for a total of 2, again, feet or meters, depending upon what we're measured in here. So the difference between where I start and where I end is 2 feet or meters. So now let's take a look at total distance traveled. For that, it might be helpful to look at a graph of our velocity function here, and we'll notice that my velocity starts negative, but then turns positive. So from 1 to 3, during that first second, my velocity is negative, which means I'm going to be moving backwards. And during that next second, my velocity is going to be positive, so I'm going to be moving forwards. Now, so we need to figure out where my velocity is 0. In this case, we can sort of see that it's going to be at 2 from the graph, but just to be sure, we could say, when will my velocity be equal to 0, which we can factor out, and we can see that my velocity will be 0 at time 2 and negative 2, the 2 being the one that we're interested in here. So now, to find the total distance traveled, we're going to separately find how far we move here. So we're going to integrate from 1 to 2, the velocity function. And then separately, we're going to integrate from 2 to 3, the velocity function. Now, this integral from 2 to 3 is going to be positive because my velocity is positive, but this integral from 1 to 2 is going to be negative. So we just want to count this as a distance, so we are going to add some absolute values here to make this quantity positive. If you want to, you can add absolute values here too, even though they're not necessary for that particular function. Going through the calculations, it turns out that this integral is negative 5, and this integral here is 7. Notice if we added these without the absolute value, we'd get the 2 displacement that we saw earlier, but with the absolute values, we add these and we get 12 feet or meters, depending upon what we're measuring in, and that is the total distance traveled, showing that our object moved 5 feet or meters backwards, and then 7 feet or meters forwards, displacement of 2, total distance traveled of 12.